Hello everyone, today I'm going to talk about a very important sector in mathematics called matrix. So at first we'll try to understand the definition of matrix, and then we'll try to use an example to visualize what matrix actually is. Then we'll use a lot of examples of different fields like science, technology, businesses, social science, and so many other sectors where we apply matrix for solving real life problems. So at first, let's try to understand what matrix actually is. So a matrix is a rectangular array of numbers arranged in rows and columns. So each numbers inside a matrix is called an element, and its position is identified by the row and column it belongs to. And matrices are used as a tool to organize data, solve equations, represent real-life systems in a simplified mathematical form. So the elements used in a matrix, it can be number, it can also be alphabet, and any kind of sign which represents a certain data. So let's try to understand or visualize matrix. So we are taking an example of a football match. We all are familiar with football matches, so we all watch it. So we have three players, Messi, Neymar, and Ronaldo. So it's unlikely that these three players will be in the same team. But we, for the purpose of understanding matrix, we can take this example that Neymar, Messi, and Ronaldo, three players are at the same team. So let's try to understand it. So Neymar passed the ball to Ronaldo for one time, and Messi passed the ball to Neymar for one time, and Neymar repassed the ball to Messi just for one time. And Messi passed the ball to Ronaldo for two times. Ronaldo passed the ball to Messi for two times. So this is an example we can easily visualize it using our human brain. But the same thing, if I ask the same question to you, that what are you going to do to make it understandable or visualizable for computers? Because computers don't understand this kind of pictures or images or any kind of stories. They just understand numbers. So we need to make it visualizable for computer through some numbers. So let's try to understand it. So here is a matrix. We can create this matrix from the story we have already talked about, the visualization we have made in our previous slide. So we can say that Neymar cannot pass the ball to Neymar himself. So it's unlikely to happen. And at the same time also, Messi cannot pass the ball to himself, and Ronaldo also cannot pass the ball to himself. So here is the matrix that Messi cannot pass the ball to Messi himself. That's why the value is 0 here, and Ronaldo also cannot pass the ball to himself. That's why the column here represents Ronaldo and Ronaldo. That's why it's also 0. And also Neymar cannot pass the ball to himself. That's why here the value is 0. Now Messi passed the ball to Ronaldo for two times. That's why the value of first row and second column is 2. Messi passed the ball to Neymar for one time. That's why the value of first row and third column is 1. And Ronaldo passed the ball to Messi for two times. That's why the value of second row and first column is 1. And also we have already talked about that Ronaldo cannot pass the ball to himself. That's why the value of second row and second column is 0. And the value of second row and third column is 0 because Ronaldo didn't pass the ball to Neymar. And also in the same way we can also explain the third row. So we have successfully made a matrix using this football's example. So this is how the matrix actually works. We create matrix from a lot of real life examples to make it visualizable, understandable for computers. And now let's talk about the application of matrix. So the first application of matrix is in computer graphics. We are engineering students. We all have used apps like Blender, SolidWorks for making 3D objects, for designing 3D objects. So while designing a 3D object, we need to spin the object, we need to rotate it, we need to move it in X axis, Y axis, and we need to do a lot of things in the 3D environment. So while performing those 3D works or 3D those works in this 3D environment, we need to work with a lot of data at a very short time. So computer graphics high performing graphics made it possible to work with a lot of data in this 3D environment. And also we are familiar with a lot of animation movies like for example Jurassic Park, and also we have seen a lot of animation movies. So while making those animations or working with 3D objects or designing 3D objects involves a lot of processing power, involves a lot of data, and there is a sector in mathematics called matrix operation. So we use matrix operation for working with a lot of data, and which makes parallel computing possible. And when we talk about parallel computing, so there is a word comes up in your mind called NVIDIA. You know this man, his name is Jensen Huang. He is the founder and CEO of NVIDIA. And there was a battle between Intel and NVIDIA for quite a long time. That which computing is better? Is it series computing or is it parallel computing? So at first we need to understand the difference between series and parallel computing. Then we will be able to understand what is the application of matrix in parallel computing is. So series computing means sending data one after another. But while we're talking about parallel computing, then we can say that we are sending a lot of data, or we are using a lot of data simultaneously. And obviously we need to use matrix for working with a lot of data. So NVIDIA uses this approach in their latest microchips like the RTX series and Grace Hopper super chips. These chips use special hardware called tensor cores to perform millions of matrix operations simultaneously, making animation smoother and graphics more realistic. So in future, as NVIDIA progresses and their research on parallel computing progresses, we'll be able to see more realistic 3D animation movies and more realistic 3D games in upcoming future. So the future is going to be so much of enthusiasm. Now let's move to the next application. The next application of matrix is in engineering and robotics. So when you're talking about engineering, it can be mechanical engineering, electrical engineering, robotics engineering, it can be civil engineering, any kinds of engineering. You need to do a course on matrix. Why? Because you cannot think about any field of engineering without the application of matrix. For example, if you talk about electrical engineering, we need to use those matrix-based calculation for solving complex circuits. So when you talk about mechanical engineering, when we talk about the visualization of a complex systems, so when we talk about force, when we talk about the movement of a complex robotic system, we need to use this sector of mathematics called matrix. So in robotics, matrix helps in controlling the motion and orientation of robotics arms using a method called kinematics. So we need to work with a lot of data while working in robotics. We need to talk about input data, we need to use output data, the sensor reading, a lot of different kind of data we need to work on while making a robot. So working with those lot of data is possible because of the application of matrix in robotics. Now let's move to the next application, is the world of physics. So I think I don't need to explain the application of matrix in physics, because we cannot think about the world of physics, our physical world with the application of matrix. When we talk about quantum mechanics, we can talk about theory of relativity, we can talk about every sector of physics called nuclear physics. It can be waves and oscillations, it can be solid state physics, any kind of physics. We need to use matrix to explain a complex physical theory. For example, we can think about quantum mechanics. So there is a thing in quantum mechanics called quantum state of a particle. So we need to work with quantum entanglement, quantum superposition, and so many data of a quantum particle. So when you think about a quantum system where a lot of quantum particles are involved, we need to explain the quantum state of all the quantum particles at a certain or at a given time. Also, we need to explain the quantum superposition of all the particles of a quantum system. So we need to work with a lot of data while talking about the quantum states or talking about quantum mechanics. So yeah, matrix calculation make it possible to work with a lot of data. And also when we talk about the change of quantum state of a quantum particle, so when you think about a quantum state, a lot of particles are involved in a quantum system. So all the particle of a quantum system change their quantum state simultaneously. So if we want to explain the entire quantum system, then we need to use this sector of mathematics to explain them properly, explain their entanglement and their superposition. Now let's move to the field of computer science. We can use matrix in computer science for explaining so many things, called, for example, algorithms. We use matrix especially in search engines and artificial intelligence. We can also use matrix in network theory to represent graphs and connection. We can use those matrix in image processing, where an image is treated as a matrix of pixels. We can use them in artificial intelligence and machine learning models. Because those things, artificial intelligence and machine learning models, heavily depend on matrix operation for training and prediction. So we cannot think about our modern world, the modern computer world, or the future we are going to witness because of the welfare of computer science. We cannot think about this world without the application of matrix. So we are going to use matrix for developing so many futuristic projects of computer science and engineering. Now let's move to the next application of matrix. It's economics and business. In business and equation, matrix can be used for in diverse application, in diverse field. Like we can use matrix for representing input-output models of the economy. We can analyze the profit and loss using financial data. We can use matrix for solving optimization problems using linear programming. Also, economists use matrix to predict trends, analyze data, and make decisions about resources. And also, we can take the example of share market. So when we are trying to predict share market, we need to use a lot of data. We can use matrix there for working with data of so many different companies. I'll just take an example. We have taken the example of a company called BrightTech. So the sales manager of BrightTech want to compare monthly sales of 3 products called smartphones, laptops, and smartwatches, and 3 different regions called Dhaka, Chittagong, Sylhet, because they have 3 different branches in 3 different districts in Bangladesh. So here is a matrix. We have a few data on the matrix: 120, 150, 190, 130, 110, 60, 80, and 70. So if you look it properly, I think you'll never be able to understand it at first glance. But if I explain it to you, then you will be very happy after understanding it. So here we have rows and columns: row 1, row 2, and row 3. So here the column 1 represents smartphone, column 2 represents laptops, and column 3 represents smartwatches. So if I ask you a question that how many smartphones were sold in Dhaka, as column 1 represents smartphone and row 1 represents Dhaka, so we can say that 120 smartphones were sold in Dhaka. If I ask you the same question that how many laptops were sold in Chittagong, as column 2 and row 2 represents the laptops and Chittagong, so we can say that 130 laptops were sold in Chittagong. So this is how matrix can be used for representing the selling data of a company. The next application is in cybersecurity. So while talking about cybersecurity, we need to know about 2 things called encryption and decryption, and also another thing called private and public key. So what actually encryption means? So if I want to send a data called how are you So while sending the data, anyone can easily hack those data and get this data and read my message. So it is very much problematic. But encryption is the system that made it possible for make it safe, make the data safe and free from any kind of hacking. For example, the sentence called "How are you?" So after encryption, we have turned the number in a bunch of numbers made up of rows and columns, and so we have sent the numbers to the sender, to the receiver. The receiver have used the number, so the receiver have the decryption key to himself. So he decrypt the number using the decryption key, and he have received the number. He after decrypting the numbers of those rows and columns, he have got the message called "How are you?" So in this way, matrix can be easily used in cyber security for this encryption and decryption system. So it's a very broader process, so it will take a lot of time to explain the entire encryption and decryption system. So in short, as we have already talked about, we can use matrix for encryption and decryption and make the internet safer, or the messaging system very much safer and free from any kind of hacking. So yeah, here we are near at the ending point of our presentation. So it will take an entire day to explain the uses of matrix in so many other sectors like genetic engineering, social science, nuclear science, accounting and finance, and so many blah blah blah, and so many other sectors. So we need to conclude here because the video is getting so much longer. We have talked about different sectors like science, engineering, businesses, and those sectors where we can use our matrix in our daily life. So here is it. So matrix can be thought as a blessing for us in modern life. We cannot think about the world of computer science. We cannot think about the world of robotics, 3D design, animation, stock market analysis, and so many other things in our everyday life without the application of matrix. So it's one kind of blessing for us. Thanks for watching. Thank you very much.